Have you ever watched television and you see these ads for this J.G. Wentworth company? Let's suppose that we decided to sue and the jury decided that that guy's worth $4 million dead and his family should get $4 million. The insurance company is not going to pay $4 million. They're going to create something called a structured settlement. And they're going to pay you, maybe they're going to pay you $1 million now and $1 million next year. And, then $500,000 and $500,000. And, okay? They're going to give you that money spread out over 10 or 15 years. They're not going to want to pay you right away. Okay? This right? Or A equals V e to the minus RT. That formula lets you take each one of these dollar amounts and figure out what it's worth now, add them up, and see if they're paying you anything close to $4 million. Okay? If you go to work for this company, you say, hey, I want the money now. Well, you go to these guys and you lay this out, and they're going to use this formula, and they're going to figure out what this is worth now, and then they're going to offer you less than that. Okay? But these guys have people working for them who are doing this. You might get paid just as a consultant to do these kind of things, right? And you're probably actually not going to use that because it's discrete, but you get the idea. We do these kind of problems all the time, okay? And related to that then is we're going to go out and do research and do consulting on things like population growth, GDP growth, okay? All of that kind of stuff is continuous, and the future is going to be defined by that. All right? So we just need to practice this because practice is good. Okay. Now, just a couple little calculus-y things that go with this. Yeah? Little calculus-y things. The derivative of the log is 1 over t. These things are real easy, right? Derivative e to the t, e to the x, dx is e to the x, right? Derivative e is e. No? Yeah. Derivative e to the t dt is e to the t. Life is just easy. Derivative of e to a function of t, like rt dt, is first derivative of t e to the function of t. Okay? So if we have e to the rt, the derivative of e to the rt dt is r e to the rt. Okay? Really simple derivatives. Really simple derivatives when we're dealing with e. Okay? So it's rate of growth. And remember that we're talking about a continuous or an instantaneous rate of growth here, not a Yeah. Not a discrete rate of growth. Okay? Yeah. Yeah. So exciting. Let's just do 3 quick problems so that we have clean, hopefully clean examples. Okay? Let's suppose that you have $5,000 right now, and you're going to put it in a stock fund, right? And you believe that stock fund is going to grow by 4% per year, compounded continuously, and you're going to have to tie up your money in there for 5 years. What would that $5,000 be worth, compounded continuously, at the end of that time? Okay? Well, the value would be AE to the RT equals 5,000 e to the 0.04 times 5. Okay? Is 5,000 e squared? Not really. 0.2. Yes? E to the 0.2. So that's 5,000 1.2214. It would be worth $6,107.01. Is that exciting? $5,000 at 4% for 5 years turns into $6,107.01. Okay? Easy? Easy squeezy peasy? Okay. So, suppose you have an offer that you give someone money now, and they're going to pay you $5,000. Five years from now, and you decide that your own personal interest rate is 10%. Okay? Your discount rate. It turns out, and one of the things that economists study is what individuals do for their own personal discount rates. It turned out that individuals, us, we don't look very far into the future, and our personal discount rates are probably like 20 and 30%, which are really, really high. And a lot of economists say, well, that's, irrational, but it's not. Okay? It's just the way people are. So remember, this now is going to become AVE to the minus RT. So the present value is 5,000 e to the 0.1 times 5. It's minus 0.1 times 5 equals 5,000 e to the minus 0.5, right? Which is 5,000 times 0.606. 5 equals $3,032. So if someone says to you, give me 3,000 now, and 5 years from now I'll give you 5,000 at 10%, it's a deal. It's even money, right? If they said to you, you give me 2,000 now, I'll give you 5,000 in 5 years at 10%, you're better off. Okay? On the other hand, if instead of that you just look at the interest rate and say, hey, I can get 2% interest. If we redid this with this being 2%, right? Yeah? Then instead of the trade-off being 3,000, right? It's more like 4,500 turns into 5,000. Okay? It's the toughest choice in doing these things when we do them in the real world is figuring out what the right interest rate to use is. Okay? So let's take the third example here. Let's take the U.S. And in 1950, there were 150 million people in the U.S. And in 2020, there's 330 million people in the U.S. How fast did we grow? What was our growth rate? Okay, so remember we have V equals A e to the RT. Well, V is 330, A was 150, e to the R times 70 years. All right? So we're going to take the loggy thingy of both sides. So log 330 equals log 150 plus, yes, 70R. Yeah. So, again, I'm not the cleanest writer here. That's 5.799 equals 5.01 plus 70 times R. That's 0.789 equals 70R. R equals, right, 0.789 over 70, which is 0.011. Good? So the population of the United States has grown a little over 1% a year for the last 70 years. Okay? Those are the three kinds of problems we're going to bump into most often. Right? This is find the future value. This is find the present value. And this is find the growth rate. Happy?